Hello everyone. So today we are going to cover longest word in dictionary through deleting. So we are given an input of a string yes and a list of strings d, and we have to return the maximum size of a word that can be formed from the string yes that is present in the list dictionary d. So how do we do it? Let's understand this problem with an example first. Here in our given example, the first word is ALE. You can actually form ALE from the given string yes by deleting the other characters, and it is of size 3. So moving on to our next word, apple. Apple also can be formed from the given string yes. Moving on to the next word, monkey. Monkey cannot be formed because the characters doesn't match in string yes, so that we cannot form monkey. And finally, PLEA, you can form PLEA from the given string by deleting the characters from A to C, and it is of size 4. And the other word we formed is apple, that is size 5. So now from our dictionary, we can form three words from the given string yes, and which is the maximum size or which is the longest. Apple is the longest, so we have to return apple as our output. So this is the problem statement says. So when I first saw this problem, the idea or the intuitive approach that hit my head was longest common subsequence. So I plan to find a longest common subsequence between every word and the given string. And if the longest common subsequence found is the word itself, then I added it to my result. Finally, return the longest word that has formed. For example, from my string ALE and comparing my string S, the longest common subsequence that can form is ALE itself. That means you can form the word ALE from the given string S. So I added ALE to my result first. So once that is done, moving to apple. Apple is again the longest common subsequence between the word S and apple. So again, I'm updating my result to apple because this is a longest than ALE. So moving on to monkey, the longest common subsequent you can form monkey from the given word is E, because no other characters are matching in yes, E is the only character that matches. So since E is less than apple, we are not updating our result. Moving on to PLEA, again PLEA is the longest common subsequence, but we are not updating our result because it is of size 4, but apple is of size 5. So finally we are going to return the result. Here I faced two complications. The one is the time limit exceeded. As I submitted the solution, it runs fine, it works fine, but I couldn't run it within time. The second thing is, consider this case. So here in this case, if we are applying the same logic, the first word A can be formed from the string by deleting the three other characters. So we are updating our result to A first. And then moving on to BA. BA is again can be formed by deleting AB from the string. So I'm updating my result to BA. So again AB, we are checking AB can be formed from the string yes, but it is of same size BA. So I'm just ignoring this AB and moving on to C. Here C cannot be formed. So I'm returning the result BA. But the output of this example is going to be AB. Why? Because out of BA and AB both are of same length, but AB is lexicographically sorted or lexicographically lesser than compared to BA. So this is going to be our output. This is the second complicated thing I faced in while doing that solution. So to reduce the time complexity, I sorted the list from longest to smallest string. So here I sorted my given list D from longest to smallest because we need to return the longest string that can be formed from the given string yes. So the first word from the list that matches or satisfies our criteria, that is that can be formed from the string, is our output. We don't have to check the other strings at all because we need to return the longest. So by using that, first checking monkey can be formed. No, monkey cannot be formed. The second string is apple. Whether apple can be formed from string yes. Yes, it can be formed. So this is going to be our output. We don't have to check the rest of the strings. So instead of checking longest common subsequence, because finding longest common subsequence is another uh, extra work we are doing. We don't actually need that to this problem. So what I actually did, I started iterating the strings with two pointers. So now A, B, P, C, P, L, E, A and apple. So I'm keeping a pointer I at my string yes and j at my string from the list d. So every time I iterate I is gonna be our scanning element. It moves every time we iterate, and j moves only if the character matches. So let's start moving our I and j. So a and a matches. So in this case both I moves and j moves to the next character. Here b and p doesn't match. So we are just moving to the next character to I but not j. J is gonna stick to here because we are checking whether we can form this string from d from this string yes. So here P and P matches. So we are moving our I and J. So I move to C and J moves to P again. So here C and P doesn't match. So we are moving our I to P and J still here at P. So in this case, P and P matches. So both of the pointers move. So here I moves to L and J moves to L. J and J again matches. So we move to L, E. So E and E again matched. So in this point, we are checking every time whether J meets length of the given string. That is, the length of the given string is 5. J starts at the first index and moves till fifth index and it again meets 5. So in this case, it means we formed the word we found the word from D in the string yes. So if the j matches the length of the word, then we found our maximum word that can be formed by deleting characters from the string yes. So we simply return this word. So this is going to be our second approach. This code can still be optimized, but before that, let's see how are we going to code this and then move on to our optimal solution. So here is the longest common subsequence solution that didn't work because of the time limit exceeding thing. So here I'm sorting my list based on the length. So if the length of any two strings in the dictionary itself is equal, then I'm checking which is lexicographically goes first. So I'm sorting the list in descending order. If the length is equal, then I'm comparing both the strings and align them based on its lexicographical order. So once that is done, I'm going to have two pointers I and j. So I'm going to loop them. I goes till the length of the given string and I'm checking if I'm iterating every word from the list. I'm checking whether the character at index I of of given string is matches with the string in the dictionary. If it matches, then I'm gonna iterate both the pointers. That is, in for loop, I will be iterated automatically for every scan or every iteration. J iterates only if the character matches. Finally, I'm checking if J reaches the word dot length, then we found a word that can be formed by deleting the characters from yes. So we are just simply returning the word. If not, finally, we are returning an empty string. So let's run. Yes. So our solution runs in 21 milliseconds. We can further make it even more optimal. So let's see our approach 3. So far we have found whether we can form the string from D from string yes by keeping the pointers I and j, and I goes or iterates the complete word yes every time it encounters a word in D to check whether we can form the word this word from this word. But there is a technique. If the word doesn't exist or we cannot form that word from yes, but still I iterates from the index 0 to till the length of the string yes. To avoid that, we are going to use another technique. If we know that we cannot form this word from the string, we simply skip and move to the next word. So how do we do that? To do that, I'm going to check whether yum exists in the given string or not. Simply it just checks whether m exists. No, m doesn't exist. In this case, you cannot form this word at all. So simply you can skip this word and move to the next word apple. So here to check apple, we are just checking whether a exists or not. Yes, a exists. So next we are moving to check b exists or not. But what if the word is p, b, a, c, p? Then still it satisfies P exists, A exists, but we cannot form the word because these characters are rearranged. So to check that, we are going to use a predefined function from Java, that is index of. This method is going to help us to find the index of every character. So first we're going to start with A. We are going to find the index of A in the given string. It is present in the 0th index. So now we are going to consider the string only from the first index till the last index and find P in this range. And once we found P, we are going to split this and consider searching the next characters only after the index of last found P. So now next is another P. We found one more P here. So we're going to split the string and further search the rest of the elements only after the range from last found character. So by doing that, if all the characters returns an index, which means this word can be formed from this word. If any character search gives us -1, which means the character is not existing in that range, so we cannot form the word, so we can simply skip the word and move to the next word. So what is the advantage of this from the previous method? In the previous method, both pointers I and j iterate completely to the string even though it doesn't have the character. For example, in our monkey, though we cannot form monkey, it still iterate through the string completely. But here, if it found yum doesn't return any index, it returns -1, which means in the first character itself, it skips the loop and move to the next word apple. So by this, it reduces a lot of time. So let's see how are we going to code it. So here I'm still gonna keep this sorting as of now. Inside every word, I'm gonna call or check a helper method is the word is sequence of that word is sequence. If it is yes, then I'm gonna return that word because we have sorted the words from longest to shortest. So the first word satisfies this sequence is gonna be the word. The same technique we used in the previous algorithm. So public, it is gonna return a boolean value whether true or false. So I'm gonna initialize my j pointer to -1. So in a for loop, it is gonna check so this function is gonna check whether the character at I is returning any index from the string B. A is the word from dictionary and B is the actual word or string yes given. So it is going to check whether in this character has an index from the string B. And why we are specifying this integer value here, it is once J is found, that is the last index of the character is found, it is going to check the remaining character from the next index. So this indicates search that character's index starting from this index. By using that, we are going to get J. If any character returns -1, that is if J is equal to -1, then return false. Straight away we cannot form the word. Or if it completes the iteration, which means we can form the word, so return true. Let's run this. Yes. So again, it runs fine, but it takes 13 milliseconds, which is actually a better solution than the previous one we have submitted. But still, we can make it some more optimal by removing this sorting process. This is taking n log d time where to sort all the strings from the given list. So let's remove this sorting completely, and I'm gonna iterate and check for every word in the D, but I'm gonna have a result variable. I'm gonna check the sequence only if the length of the result is less than the word currently we are going to iterate it. If the word's length is gonna be higher than the previous result we stored in result variable, then we gonna call the sequence and check. If not, if it is not greater, if it is lesser, we can simply have a result and move forward to the next solution. Or if it is equal, if the result dot length is equal to word dot length, then we are going to check whether it is lexicographically less. If not, if it is lexicographically higher, then we don't have to do this. We don't have to check whether it is a sequence and update it. If it is lexicographically lesser, then we are going to do the sequence. So we are checking if it is equal and word is less than 0, then which it means it is lexicographically lesser. So if this is the case and the new word satisfies the is sequence, then assign result is equal to word and finally return the result. So overall what we did, instead of sorting, we removed the sorting code and we are checking if the new word is greater than the result, then we can check whether it is a sequence and update. If not, if it is lesser than the word, it is obviously not going to be our output. Or if there is another case that if the words are equal length, then we have to do only if one word is lexicographically lesser than the other word. If not, again it cannot be our solution, we can move. So we are checking if the word is equal and lexicographically lesser than the actual result, then we gonna check if it is our sequence, then finally update the word. It should be a string. Okay, we are assigning the word result to word. Yes. Yes, our solution is running in 8 milliseconds, which is far better than the first one we have submitted. So thanks for watching. If you like the video, hit like and subscribe. Thank you.